All right. Hello, everyone. Um, I am working my way through this review slowly. So we've done limits, we've done tangent lines, and we've done critical points. The next thing I want to do is the maxima and the minima of certain functions on given intervals. So this is going to be essentially more of the critical points exercise with the additional step at the end that I'm going to do one of two things. Either I'm going to do a first derivative test or second derivative test. And I think I'll demonstrate that once, but it's a little bit redundant. It's like the hammer, it's a little bit much for something simple. Or I'm going to show you the slightly less rigorous method that I'm more prone to use when I'm in a hurry, which is to just take all the critical points, plug the x values into the function, and see which one is the maximum and one is the minimum, because I am assured that the max or min has to occur at one of the critical points. So let's get started here. Looks like the first one we've got here is f of x equals x cubed plus 3x squared plus x minus 8. Wait, that's from the wrong problem. Whoops. Sorry. First one is cube root of x. So let me fix all this. Blah. 1/3 on the interval -1 to 1. So as with taking critical points, our first step is going to be taking the derivative. So because remember, there are three kinds of critical points, either where the derivative doesn't exist, where the derivative is 0, or the endpoints of a closed interval, right? So I'm just going to say here that by the power rule here, my derivative is going to be 1/3 x to the 2/3. So in other words, 1/3 x to the -2/3 is really what that is. And so now I have two questions to ask. Where is this equal to 0? So where is f prime of x equal to 0? And the answer to that is nowhere. Because for this to be 0, its numerator would have to be 0, and 1 does not ever equal 0. And so where is f prime of x not defined? And we do have such a point. That's going to be at x equals 0, right? Because then I would end up dividing by a 0, and that's bad news. So my critical points for this function, assuming that I can remember how to spell critical, are x equals -1, 0, and 1. So, okay. I might have already done this problem, I'm not sure. Okay, I did the next one. So, okay, here's what I'm going to do. I'm going to make a nice little table. And this table is going to have 1, 2, 3, 4 rows. And I'm going to make one column for the interval. I'm doing first derivative test here. I'm going to have an interval, or sorry, a column for my, what's called my test value. I'm going to have a column for the sign of the derivative. That's the SIGN. And so I'm going to also have a column about what I conclude about the function. Is it increasing or decreasing? So horizontal line, and now my intervals are just going to be the big interval chopped up into pieces by where the critical points are. So I'm going to divide this wherever there's a critical point. And so the first such interval is going to be -1 to 0. And so for my test value, I think I'll pick just whatever is smack in the middle. So let's say -1/2. That is going to give me, let's see, that looks like a positive number because I'm taking the cube root of that and then I'm squaring it on the bottom. So that's going to give me something positive. I conclude that on the interval -1 to 0, this function, that's f, not f prime, is increasing. I can go through the same process for 0, 1. You might want to pause the video and do it yourself, but you're going to get the same thing. So I'm going to close up my thing here, and I get a pretty little table. So what does this tell me? In particular, what does it tell me about the critical point 0? Well, it's increasing to the left of 0, so it can't be a min because I was increasing before I got to 0, and I'm increasing after I got to 0, so it can't be a max. So 0 is just kind of a place where the derivative does something weird, but it's not a minimum or a maximum. So really what this function is doing over this interval is it never stops increasing, right? So wherever you look, it's increasing. So what that means about my max and min is that the min has to be the furthest left point, and the max has to be the furthest right point. So that is an analytical perspective. I could also be a little bit more mechanical and just plug all the points in. So -1, let me do 0 first. X equals 0 is neither a max nor a min. X equals -1 is a min. Since when I go to the right of it, I increase and I can't go to the left of it. And x equals +1 is a max because when I go to the left of it, I go down and I can't go to the right of it. Now, if you're asking for the maximum of a function, you generally want the y value, so I should plug this in. So let me say the global minimum on this interval is going to be -1, and then I plug that into my function and I get -1. The global maximum is just going to be 1, 1. So x is 1 and y is 1. Okay. Hopefully these other ones should go faster now because I don't have to do first derivative test really but once. So the next one is going to be, f of x, f of t, I think. It might be g of t. Yeah, I don't know that really matters, but whatever. So that's going to be t squared over t squared plus 3. And that's going to be, again, on the closed interval -1 to 1. And let me outdent that. There we go. Okay, first thing I'm going to do, I have to take a derivative. I really don't want to use quotient rule on this. I certainly could, but I'm kind of in a hurry today, so I want to maybe simplify this fraction out a bit. So let me come back up here and say t squared plus 3 minus 3 over t squared plus 3. And so that's going to be 1 minus 3 over t squared plus 3. And there's that for you. So now the 1 is easier to take a derivative of, and the 3 over t squared plus 3 is not going to pose a problem anymore. So let's do this. Then g prime of t, the 1 is going to differentiate out, and then I'm going to have negative 3. This is t squared plus 3 to the minus 1 that I'm really taking the derivative of here. So the minus 1 is going to come out ahead of the thing, and I'm going to have a minus 2 sitting here. But remember, I have to account for chain rule. Chain rule gives me a 2t from derivative of t squared plus 3. And so if I clean this up a bit, I think I'm going to get um, 6t over t squared plus 3 squared. Well, this looks bad, but it's not actually terrible. So the next thing I'm going to do is ask, where is g prime of t 0? And the answer is, for this fraction to be 0, the numerator must be 0. So I can say this is going to be at t equals 0 and nowhere else. And then my next question is, where is it undefined? And the answer is it's defined it's undefined nowhere. It's defined everywhere. So the critical points are, again, -1, 0, and 1. So I don't want to do the first derivative test business again. I'm just going to do it the short way and say, uh-oh, that should be t, not x. I'm just going to say g of -1. That's going to be, it looks like 1/4. G of 0 is, of course, going to be 0. And g of +1 looks like 1/4 again. So x equals -1 and x equals +1, sorry, t, not x, I get in a habit, are both maxima because they have the same value at either end. In fact, this is an even function, so you could have figured that out right away. And so t equals 0 is a minimum. I forgot to type 0. T equals nothing. That's the same thing, right? Okay. So there you go. Next one, yuck. Okay. This h of t. Yep. And so that's going to be t over t minus 2 on the same interval again. This is a situation where quotient rule would be maybe a little bit faster than doing the same thing. So I'm going to take my derivative first. And so that's going to be on top. I'm going to take the derivative of the top first times the bottom minus the derivative of the bottom times the top. So that's going to be 1 times t minus 2 minus t times 1. And then on the bottom, I'm going to have t minus 2 squared. And so if I clean that up a bit, it looks like I'll get -2 over t minus 2 squared. And so now I can ask, where is h prime of t 0? And the answer is it's never. Where is it undefined? And the answer is it's not defined if I let t equals 2, but that's not inside my interval. So I'm not going to consider it as a critical point on this interval because it's not in this in this interval. My voice cracked. Okay. Those are my vocal exercises. I just sing Bad Romance. There you go. I'll say the interval. I won't be possessive with it. So the only critical points this function has on this interval, my endpoints, right? T equals -1, t equals +1. And I can just plug those in, and that's pretty easy. H of -1 equals, that looks like it's going to be a positive 1/3. H of +1 is going to be -1, 1 over -1. I keep saying x. So t equals -1 is a max, and t equals +1 is a min. Okay, so let's see. What was I going to say? I can't remember. Oh, right. So this accords with the fact that I already know. So I took the derivative of this function, no matter what t is, as long as it's not 2, then this is going to have a negative derivative, right? So no matter where I am, as long as this thing exists, it's negative. So it's decreasing over the whole interval because the interval doesn't include the part where it blows up. So it makes sense that the biggest value would be at the left where it's decreased the least and the smallest value on the right. All right. So let's move on. Yuck. Y equals 4 minus absolute value of, let's say t. No, I'm sorry. I'm going to make this an x because that's no good. Okay. So this one kind of throws you for a little bit of a loop because the first thing you might be expected to do in this situation, what I've done with every previous problem is I took the derivative first, right? Well, how do you take the derivative of absolute value? That's not one of my basic rules, really. It's a little bit more subtle. So the first thing I would say is I want to go back to the definition of what absolute value is. And typically in calculus, we think of it as being defined as a piecewise function. So here's what I want to say. X minus 3 is equal to the positive x minus 3 if x minus 3 is positive or 0, and negative x minus 3, which is 3 minus x, if x minus 3 is negative. Uh-oh. I forgot to end my, okay, there we go. There's the bracket, okay, cool. So, okay, so I can take the derivative of a piecewise function. So here's what I'm going to do. I'm going to say I have to be a little bit careful here. But I'm going to start with y prime. The 4 is going to differentiate out. And then I'm going to have -1 times the derivative of x minus 3, absolute value. And so let me write this first. And then we'll talk about it. So, let's see. So here's what I'm going to claim. To the right of 3, then x minus 3 is increasing, right? Absolute value is increasing. To the left of 3, it's decreasing. So my derivative is 1 here and -1. So how did I get this? This is the derivative of that. This is the derivative of that. And so what am I going to do here? Well, there's two things I need to look for. And the first thing I need to remember before I do this is that absolute value has a corner at the base of the V shape, which means it's not differentiable there. So you have to be a little bit careful with piecewise functions because usually at the points where they join, so the I don't know how to call them, I think of them as like the joints of it. So absolute value has what I would call a joint or a corner at x equals 0. Absolute value of x minus 3 has such a thing at x equals 3. That's how I think of it. And at these points, the derivative, barring a great coincidence where it's the same on the left-hand side and the right-hand side, doesn't exist, because remember, the derivative is really a limit. And a limit has to be the same coming from the left-hand side or from the right-hand side. And so there's no value I can define for the derivative here at x equals 3 that will make sense. So we say that that derivative does not exist. Okay, that was a lot of words. Point is, 3 is going to be a critical number because it's non-differentiable here. That is the only point at which y is not differentiable. And so the only other thing I have to ask is, where does y prime equal 0? And nowhere and never does it equal 0, right? It jumps from -1 to 1 in this case. So I'm going to just plug in now. So my critical numbers, my critical numbers, it's harder to type than you think, are x equals, let's see, I'll say critical points. Critical numbers is what the book has switched to using for some inexplicable reason. So I have my 3 there where it's not differentiable, and I also have my endpoints, those are 1 and 5. So when x equals 1 or x equals 5, y is going to equal, looks like a 2. That's going to be 4 minus 2 in either case. When x equals 3, y equals 4. So x equals 3 is a maximum, and x equals 1, x equals 5 are minima. Okay, that one was a little bit trickier because we had to consider more carefully what the derivative of this thing was. But once you get over that, it's quite straightforward. So just remember how continuity and derivatives work and you'll be okay. All right. Uh-oh, I missed a $sign. There it is. Okay. I think this is g of x equals secant x on, I'll say on, negative pi over 6 to positive pi over 3. I remember doing this problem already, but I'll do it again. So as with the others, my first step is to differentiate. That'll give me secant times tangent. And I'm going to, for reasons that will become apparent in a second, I'm going to simplify this a little bit. And so I'm going to convert this back into sines and cosines is basically what I'm going to do. So there you go. All of the analysis that I'm doing would go through still. So I could explain it a different way if I wanted to, but I find this to be simpler. So where is g prime of x? 0. If you were doing this with the raw secant tangent form, then you would say secant x has to be 0. Where does that happen? And the answer is never. Where does tangent equal 0? And the answer would be at x equals 0 itself, right? In this case, I know that the numerator has to be 0 for the whole thing to be 0. So I know that that's where sine is 0. And the only place on this interval here on which that happens is going to be x equals 0. And then where is g prime of x? Undefined. Now I want to say a few words about this because this one has problems where cosine of x has problems. Or sorry, where cosine of x equals 0, right? Because that's the only way I'm ever going to get this thing to divide by 0. So if you think about it and you remember where cosine is 0, that's going to be at x equals pi over 2 plus some integer multiple of pi. But so on the positive side, the first place where I would have a problem is pi over 2. On the negative side, it would be negative pi over 2. So that's pi over 2 minus pi. But that is not going to happen on my interval. It's just not big enough. So my critical points are x equals negative pi over 6, 0, and pi over 3. And so we'll just plug all these in like I've been doing. G of negative pi over 6, that's going to be secant of negative pi over 6. I don't really have my trig functions absolutely memorized like I used to. That's a waste of time. You can always get it, unless you're doing KAAC and you're in the finals at state and you need to be able to take the secant of something in 0.5 seconds. There's no use in memorizing them. So That's going to be 1 over cosine of negative pi over 6. I know that cosine is even, so that's going to be 1 over cosine of positive pi over 6. I don't know if this is all going to fit on one line. This is going to be cosine of pi over 6, I believe, is square root of 3 over 2. So my final number for this is going to be 2 over square root of 3. 2 over square root of 3, that's right. That almost works. Let me put my display style in there and see what I get. That's better. Okay. G of 0 is 1 over cosine of 0, and that's 1. That one's pretty quick. G of pi over 3 is going to be 1 over cosine of pi over 3. Better put that in parentheses. Or, I think that's 1 over a half. So that's 2. So here's what I know. If I were to punch in 2 over square root of 3 on my calculator, I would get a number that's a shade bigger than 1. Square root 3 is about 1.732 something. I know more digits, but that's not the point. So I know that this number here is bigger than 1, but less than 2. I don't really want to figure out what that is with 2 explicit digits in my head. I just know it's between 1 and 2. So zero, where I get a 1, is going to be my minimum. And my maximum is going to come at pi over 3. And there's that problem done. All right, last one. And then I think I am done. Where's Rome? Okay, here we go. I think this is h of x. Did it say t? I'll use t. H of t equals arctan of t squared. So that being squared is inside the t, or sorry, inside the arctan, or at least it better be. I don't want to think about doing it the other way. That's going to be on the interval -2 to 1. All right, once again, I've got to take a derivative. Remember that the derivative of arctan is going to be 1 over 1 plus argument squared. So arctan x is 1 over 1 plus x squared. So in this case, I'm going to have one over 1 plus t squared times chain rule gives me a 2t. So simplifying a little bit, that's going to give me 2t over 1 plus t to the 4th, which is not a nice thing particularly, but okay. So now I can ask, where is this thing equal to 0? And I know the numerator must be 0, so that gives me t equals 0. Where is this undefined? Underfined. You didn't find them enough. The answer is never, because the denominator is never 0. That's a sum of perfect squares. So critical points are at t equals -2, 0, and 1. Okay, let's see. I could, yuck. Some of these I could do, the others I'm not so certain. I might just use Google for this one because I don't know what arctan 4 is offhand. So let me reason this out, and then I'll punch the values into Google and show you I'm right. So here's what I know. This is going to be 2 of these I can do offhand. H of 0 is going to be arctangent of 0, and I know that's 0. H of 1 is going to be arctan of 1, and I happen to know that's pi over 4. So now the answer, the thing that I have to answer is, what about minus 2? Well, that's going to be arctangent of minus 2 squared, which is 4. And here's what I'm going to say. I know that arctan for positive numbers, well, for all numbers actually, arctan is an increasing function. So if I take its derivative, that's 1 over 1 plus x squared. That's always a positive number. So I know the bigger the argument is, the bigger arctan is. So I'm going to say, without any other justification, I don't know what arctan 4 is exactly, but I know it's bigger than arctan 1. And I will check the numbers on that in just a second. So t equals 0, that is going to be my minimum, and t equals negative 2 is going to be my maximum. All right, let me prove this to you, and also see how competent Google is. So arctangent of 4 in radians is about 1.326. And arctangent of 1 is pi over 4, which I could tell you is about 0.73, but I'll let Google do it. 78, I was off by 1/20th. Oh yeah, that makes sense. I'm a dumb. Okay, so 0.78. And so there you go. That is an example of how I get by on the fly without using a calculator. I haven't needed to use a TI for a long time, except to prove that I'm already right, because I'm always right, because I'm awesome like that. I'm really not. I'm just as fallible as you are. I've just had more. Okay, I sound like a douche, so I'm gonna stop talking now. All right, I have about half of this left to do still. I have to go to Mother's Day dinner at my boyfriend's place with his family. So I'm going to do that. And then if I have it in me still when I get home, I'm going to try to record some more. So if not, I'll do it tomorrow morning. All right. Be well and take good care of yourself.